Hi everyone, welcome once more to Best Science Brain YouTube channel. Today we're trying to look at qualitative analysis for WAEC 2024 Alternative B, as you can see on the whiteboard. So we're going to run an experiment or analyze the sort provided for 2024 WAEC examination, Alternative B, and that sort is labeled F. So at the end of the experiment, we're going to identify the cation present in F and the anion present in F. So if you are seeing this video for the very first time, you are not subscribed to the channel, move down to the video, beneath the video, and the video is playing, move down and then look for the channel's name, Best Science Brain, and then look for the subscription icon, the small tiny bell under the channel's name. Tap on it only once and get subscribed to the channel. We thank our subscribers as we're about to start the experiment. We appreciate you all. So continue viewing as we move on to the questions. So move to the question. Qualitative analysis alternative B, WAEC 2024. Number 2, F is a simple inorganic salt. Carry out the following exercises on F. Record your observations and corresponding inferences. Identify any gas or gases involved. So go to question number AI that says add 10 cn cube of distilled water to F, stir thoroughly. Add 10 cn cube of distilled water to F and stir thoroughly. So before we do the experiment, we'll first of all go to the whiteboard and record our tests before the experiment. So question AI, we have F plus 10 cn cube of distilled water and stirred. So we want to add water to F and stir the mixture to see whether F is soluble or not. Okay, so this is our F, there, a white crystal. This is our wash bottle with water. We add water. I have to add about 10 cn cube. So we are not measuring the water. Just add enough water that will be up to 3/4 of the test tube of the content. You can see that. So you're not measuring the water. Just add up to 3/4 of the test tube water up to that level. Then you stir. You can look for an improvised stirrer, or you can use your thumb. If your thumb is neat, you close it and then shake it. So let's use this stirrer to stir F. Remember that F is the solid. But this time around, now, after dissolving F in water, we no longer have F solid. We now have F aqueous. F aqueous means solution of F. So be mindful of what you report or what you use reporting your tests. So we stir F very well. And as you stir F, try to fill the test tube. Fill the test tube. How are you guys doing it? Fill the test tube. Just touch the test tube and see whether it's hot or cold or warm. So what is the sensation you're having there? It's cold? Okay, it's cold. So that is it. So reactions. This is not a reaction, but this is a physical process, the solutions. Whereby the test tube feels cold. It's said to be endothermic process because heat is being absorbed. So we have this. So after stirring, you see nothing else remaining in the container. That means F dissolved completely in water to give a colorless solution. So F dissolved completely in water to give a colorless solution. So go to the whiteboard and report our work. So our observation, say F dissolved completely in water to give a colorless solution. The test tube felt cold to touch as we observe. They will go to the inference section. The inference we now say that F is a soluble salt. And then the solution is endothermic. So you take a second to view our work, and then we'll now move to the next question, AII. We'll now move to question AII that says, test the solution from AI with litmus peppers. Test the solution from AI with litmus peppers. So as we used to do, we go to the board and report the experiment first. So AII, question AII, solution from this AI. And that solution from AI means you can say solution from AI or you can say F aqueous. You see the difference between writing F and writing F aqueous. This one means solution of F, while this one means F as a solid. So you don't want to write F aqueous. You can say solution from AI, referring to this number, or F aqueous plus litmus peppers. So that's the test. So we're going to go to the observation and then the inference. So to do the test, this is the blue paper. I will slant the solution and then allow the solution to touch the blue paper only 1 second. You see, there is no change on it. So I now take the red paper, then slant the solution and allow it to touch it only 1 second. So is there any change? Yes. The red one have been changed to what? Blue. So we can now see that this solution is alkaline or it is basic. So we go to the board and report our work. So observation will say F aqueous or solution from 2AI, that will represent, had no effect on blue litmus paper, but change red litmus paper to blue. I have to mention these two colors, red and blue. So red to blue, I have to mention the two different colors. Then the inference, you now say F aqueous or solution is alkaline. Alkaline, don't say alkali, alkaline, or you say basic, not base. So let's go through the work in a few seconds. So let's go to the next question. We'll now go to question AIII that says to 2CnQ solution from AI, the same F aqueous, add 5 Cn³ of sodium hydroxide aqueous and heat the mixture. To 2CnQ solution from AI, add 5 Cn³ of NaOH and heat the mixture. So go to the board and report this work now. So question II says 2 Cn³ of F aqueous plus 5 Cn³ of sodium hydroxide, also aqueous. Then please, all these chemicals you're writing, you must present their state. When you write the formula of a chemical, you must put aqueous on them. You don't just write NaOH without anything on it. Then F is an aqueous state, except in number 1 where F is just solid. So let's go to the experiment. So this is my F aqueous. So the F aqueous, this is the boiling tube. We need boiling tube. Since we want to heat, we want to add the solution of F into a boiling tube. You heat the boiling tube because heat the test tube, the glass may crack. Use a wider tube or thicker one called boiling tube. So I'll pour some quantity of F into the place. Before we heat, remember that we are told to add sodium hydroxide first. So that's enough quantity. So I'm going to add NaOH, sodium hydroxide. So to this F. So let's add and observe. So I added enough and you see that nothing happened. There was no reaction taking place, no visible reaction. Don't say no reaction. There could be a reaction, but we'll say no visible reaction. We're not seeing it. Or we'll say no plate formed. So here we'll write no visible reaction. Or you can write no precipitate formed. Under the inference, nothing on the inference yet. So there's no inference to this reaction because you didn't observe anything, so that you are not reporting anything. Then here again, you say plus heat. So we're told to heat after adding this chemical. So the next line, write plus heat. So we're now going to heat this mixture. That's what happened. So we are heating the mixture of F, aqueous, and sodium hydroxide. So as you heat, you try to rotate the boiling tube over the burner. Don't keep it steady. Don't keep it at one place so that the heat will not crack the glass. Move it round. So allow it to boil. And then slant it not to your own face and not to your neighbor's face. So I'm very careful. So don't slant it to your own face and don't face it on somebody's or your neighbor's or your neighbor. So when you're heating and the thing is boiling up, remove it from the fire. So we're heating a mixture of F, R plus F solution, and sodium hydroxide. So it is boiling. And if you observe very well, the vapor is coming out, and that is the gas. So I'll place a red pepper. You see, the pepper has turned blue. Blue in color. So it's boiling up, I remove it. Then see the pepper has turned blue, faint blue. Anyway. So I can fan the gas to my nostril to perceive it. So I'll see it again. So that is it. The gas have turned the red pepper to blue. So we're going to carry out another test on the gas this time around. We bring a glass rod that is soaked in HCl. You can see white vapor or white fumes coming out, and the gas comes in contact with HCl. Are you seeing it? So that is it. So we now report our work. Say a colorless gas with a choking odor or smell evolved. Then gas turned moist red litmus pepper blue. Look at the color. And produce dense white fumes with HCl vapor. So under the inference section, we now write gas is NH3 ammonia. Then under it to write NH4 ammonium ion confirmed. So take a second to go through this work before we go to the next question. So question B I says To 2CnQ solution from AI, add 2CnQ or barium chloride aqueous and heat the mixture. To 2CnQ solution from AI, solution from AI is a F aqueous. Add 2CnQ or barium chloride and heat the mixture. So let's go and report our work. So on question BI, we have 2CnQ of F aqueous plus 2CnQ of barium chloride aqueous. We are asked to heat, but we're going to do this one before we do the heating. So we have our F solution aqueous. We have a clean boiling tube. So since we're going to heat, we're going to do the test in a boiling tube. So now collect 2CnQ, small amount, into the boiling tube, that F aqueous. We are told to first of all add barium chloride into it, the barium chloride solution. So we're going to add small amount into this F solution or F aqueous. So you now have, you can see, we have formed a white race with it. You can see add more. So you see it's there, white solid form inside. So white race will form inside the boiling tube. So let's report our work. Observation will say a white precipitate formed. Then we go to the inference. The inference should be the triazocarbonate, that is CO32 minus ion, SO4, that is sulfate ion, triazosulfate, which is also known as sulfite ion, then sulfide ion present. Any of these ion could be present. CO3, the letters are all capital because the different elements, C capital, O capital, S capital, O capital, and so on. So triazocarbonate 4 or carbonate ion, triazosulfate 6 or sulfate ion, triazosulfate 4 or sulfite ion, sulfite, and then sulfide ion, any of them present. Remember that they use comma all through, don't use and. Comma all through. What it means, this or this or this or that present. So these four ions, anions are being suspected. So take a minute, look at our work. Then next, the observation, the test, we're going to write plus heat. We were asked to heat the mixture. So we're going to heat this white precipitate. So we're going to heat this mixture here. So that is the next test, plus heat. So we are heating the mixture of barium chloride and F or the white PPT. I will connect this mixture to lime water in the ram button flask. So to identify the gas that is coming out. It is boiling. The gas is being channeled into lime water. The gas is coming out in large amount, even escaping. And the white PPT is gradually dissolving. So you see that the lime water has turned milky in appearance. And the white PPT inside the boiling tube had dissolved completely. So you can see that. So we can now go and report our work. So observation, we write effervescence. Effervescence means gas liberation whenever an acid is added to a substance. Or called liberating, a colorless, comma, odorless, gas which turned moist blue litmus pepper faint red and lime water milky. That's the correct observation. And then now I write also residue. Sorry, not residue. White precipitate dissolved to give either you say a clear or you say a colorless solution. So under the inference, you now write gas is CO2 carbon 4 oxide. Then CO3 2 minus. This ion confound. So take a second to go through this work as we move to the last question. So now I go to the last question. That is BII. That says to 2CN solution from AI, add 5CN cube of dilute HCl and boil or heat the mixture. I repeat, to 2CN solution from AI, add 5CN cube of dilute HCl and boil the mixture. So look at question BI and look at BII. BI says to 2CN cube of solution from AI, add 2CN cube of barium chloride and heat the mixture. So you look at then the one we did some minutes ago, and look at this one. To 2CN cube of solution from AI, add 5CN cube of dilute HCl and heat the mixture and boil the mixture. So what we did not do, remember to add. We're going to make some correction for that BI. That BI, before we heated, we added what? HCl, am I right? We added HCl to BI before we heated. Did we add HCl? Yes. We added HCl before heating the mixture in BI. So we're going to make some correction on question BI. Before the heat, HCl was added, please. So let's go to before I come back to BII, let's go to the board and make the correction on BI. HCl was added. So the correct format for that BI is 2CN solution from AI, add 2CN cube. I repeat myself, to 2CN solution from AI, that is F aqueous, add 2CN cube of barium chloride, comma, add 5CN cube of HCl and heat the mixture. So we forgot to put in that HCl. So we're going to report it. But when we did the test, we added HCl. So we're going to make the correction on the whiteboard. So this place will have heat plus heat. We now say plus 5CN cube of dilute HCl. Or you can write HCl aqueous before heat. And that is our observation and inference. So I made a correction. HCl was added after we added barium chloride. After the white pit was out, HCl was added. That's why you observe effervescence taking place. So that is it. So go to the question. Question BII says to 2CN solution from AI, add 5CN cube of dilute HCl and boil the mixture. Look at question BII and look at question BI. What's the difference between the two of them? They're almost the same thing. So the BI says to 2CN solution from AI, add 2CN cube of barium chloride, 5CN cube of HCl and heat the mixture. But in BII, you are told to 2CN cube of solution from AI, add 5CN cube of dilute HCl and boil or heat the mixture. The difference is that in BII, we are not adding any barium chloride. That's the difference. But in both of them, we're adding HCl and also heating the mixture. So in this examination, they cannot ask you Bi and Bii at the same time. So it can come in the form of what? Bi. You ask barium chloride and then heat, and then Hesse and heat. Or you ask to add only what? Add Hesse and heat without adding barium chloride. So Bi. Bii is alternative for Bi. Do you understand? So let's go to the board and report the work. So now I have here 2Cn cube of Fr plus HCl, which is a 5Cn cube of dilute HCl, then plus heat. When you put dilute here, you don't need to put aqueous. Without dilute, you have to specify aqueous close to the HCl. So let's now go to the observation, the experiment, and then carry it out. So we'll have F aqueous, we're adding HCl, and we're adding the F aqueous into the boiling tube. Then we are going to add HCl into it. So open the HCl container and then pour into the F aqueous. So we're going to expect effervescence. You can see a gas is coming. That's what effervescence. The bubble rising. The gas is coming out. Do you understand? The same gas, which is what? CO2. If I want to carry this test on it, I'll still repeat the same heating. If I heat, I bubble it into what? Into lime water. I still have the same kind of observation. That's why I say that Bi is alternative to what? Bii. Either you have to add HCl direct, or you have to add very good before HCl. Is that okay? So let's report our observation and then wind up this experiment. All right. Effervescence. The same thing we have in the other one. Effervescence occurred liberating a colorless, odorless gas which turned moist blue litmus paper faint red and lime water milky. In this case, we will not write white precipitate dissolved because we did not have barium chloride in this second case. So now right here, gas is CO2 and then CO3, 2 minus compound. So when you are writing the formula for gases or ions, they go up there. One of ions. That's very careful how you write formula. Very important before you fail. So the elements in ions are always in capital letter because they are different elements. This C is a different element from oxygen. S is a different element from oxygen. So it should be capital letters all through. You can see it. Not S small and O capital or S capital and O small letter. That is wrong. Capital all through. Look at CO2. C and O2 capital letter. And then if you come to the test column, the chemicals you're adding must always be specified in aqueous state. Aqueous. If it's an acid, you write aqueous or you put dilute in front of the formula. That will also cover it. So that is it. So we have come to the end of the experiment on Qualitative B, WAEC, May, June 2024, qualitative analysis. So the salt from our analysis, the F is, the cation in F is ammonium ion, confirmed. The anion in F is triazole that is CO3, confirmed. So the salt contains ammonium ion at the cation and then triazole ion at the anion. That means F is ammonium triazole carbonate 4. F is ammonium triazole carbonate 4. From this, you can verify our solution. So stay connected to the channel, subscribe, don't forget to tap on the notification bell if you're not subscribed. Share our videos and stay connected always. Thank you very much.